All right, we're going to move on to part two on our lesson on thermal energy. Yesterday, we talked about the terms thermal energy and heat and temperature, and how, although they're related to each other, they definitely don't mean the same thing. So, we will definitely be working more with those words. But we're going to go ahead and finish this lesson so that we can do some other activities with thermal energy. So, we're going to go ahead and move on. It says, what is conduction? There are three main ways to transfer energy as heat: conduction, convection, and radiation. Conduction is the transfer of energy as heat from one substance to another through direct contact. So that means like two things are touching each other, and that's how you're transferring the heat. It occurs anytime that objects at different temperatures come in contact with each other. The average kinetic energy of the particles in the warmer object is greater than the average kinetic energy of the particles in the cooler object. We know that things that are warmer have particles that are moving faster than things that are cooler. As the particles collide, some of the kinetic energy of the particles in the warmer object is transferred to the cooler object. As long as the objects are in contact, conduction continues until the temperatures of the objects are equal. So yesterday when we were looking at the picture of the uh, the drinks in the cooler, so this would be an example of conduction. The drinks are touching the icy water. So the warmer substance, particles are moving faster, is going to conduct heat, transfer heat directly by contact to the slower moving cooler particles until they eventually all become the same temperature and are moving at the same rate. Conduction can also occur within a single object. In this case, energy in the form of heat is transferred from the warmer part of the object to the cooler part of the object. Imagine you put a metal spoon into a cup of hot cocoa. Energy will be conducted from the warm end of the spoon to the cool end until the temperature of the entire spoon is the same. So remember that conduction is when they transfer with your direct contact. Conductors. Some materials transfer the kinetic energy of particles better than others. A conductor is a material that transfers heat very well. Metals are typically good conductors. You know that when one end of a metal object gets hot, the other end quickly becomes hot as well. Consider pots and pans that have metal handles. A metal handle becomes too hot to touch soon after the pan is placed on a hot stove. And I know that my pots and pans, the ones that I have, the pot itself is metal, but my handles are typically made of plastic so that I don't burn my hands. But if you took a look, you could find some of your pots and pans have a different handle that is not a good conductor. So let's talk about what those things are. Insulators. An insulator is a material that is a poor conductor of heat. Some examples of insulators are wood, paper, and plastic foam. Plastic foam is a good insulator because it contains many small spaces that are filled with air. A plastic foam cup will not easily transfer energy in the form of heat by conduction. That is why plastic foam is often used to keep hot drinks hot. Think about the metal pan handle mentioned above. It can be dangerous to have handles get hot so quickly. Instead, pot handles are often made of an insulator, such as wood or plastic. Although a plastic handle will also get hot when the pot is on the stove, it takes a much longer time for it to get hot than it would if it were a metal handle. So insulators, they are poor conductors of heat. I know you guys watch me drink my iced tea every day from Sonic. Sonic uses foam cups because they're good insulators. They keep the drink cold all day, right? So those would be things that don't conduct heat very well. So I love this picture down here. This is a polar bear hair that's magnified about 350 times. And you can see that the polar bear hairs have empty space inside. They're hollow. And the air actually forms as a really good insulator to help keep the bears warm. All right, so what we're going to do now is come down here and classify these objects as whether they are conductor, meaning that they transfer heat well, or they're an insulator, meaning that they don't transfer heat well. All right, so let's do the first one. Flannel shirt. Is that a conductor or an insulator? Iron skillet. Conductor or insulator? Copper pipe. Conductor or insulator? And an oven mitt. Conductor or insulator? All right. Well, we should have picked the things that were made of metal, like the iron skillet and the copper pipe, as good conductors. We know that things made of metal are good conductors. Things that are typically made of material like fabric would be insulators, like a flannel shirt. We wear those to keep warm. And an oven mitt, we know we insulate. We use that to protect our hand from the heat of a hot pan. So those would be the insulators. All right, let's talk about the next kind of way to transfer heat, convection. Energy in the form of heat can also be transferred through the movement of gases or liquids. Convection is the transfer of energy as heat by the movement of a gas or liquid or gas. In most substances, as temperature increases, the density of the liquid or gas decreases. So the particles are moving further apart, which would make sense. As we go from a liquid to a gas, we know that those particles are moving further apart. Convection occurs when a cooler, denser mass of gas or liquid replaces a warmer, less dense mass of gas or liquid by pushing it upwards. So we're talking about moving. It's moving from top to bottom because it moves up to the top, it gets heavy, moves back down again. It keeps moving around in a circle. When you boil water in a pot, the water moves in roughly a circular pattern because of convection. The water at the bottom of the pot gets hot because there is a source of heat at the bottom. As the water heats, it becomes less dense. The warmer water rises through the dense, cooler water above it. At the surface, the warm air begins to cool. The particles move closer together, making the water denser. The cooler water then sinks back to the bottom and is heated again, and the cycle repeats. This cycle causes a circular motion of liquid or gases. The motion is due to density differences that result from temperature differences. The motion is called convection current. So we can see here, this nice glass pot here shows, so the water down here is getting really hot. So the particles are expanding and getting further apart, making it lighter. So it moves up to the top. Then it cools off and gets heavier, gets more dense. So it falls back to the bottom, warms up again, spreads out, gets lighter, goes to the top, cools off, goes back to the bottom. So that's how that convection works. That's how air fryers have become super popular. Same thing. The air is moving in that convection current and it's heating things all nice and evenly because it's heating it from all directions. So that's kind of how an air fryer works too. Let's talk about radiation. Radiation is another way in which heat can be transferred. Radiation is the transfer of energy by electromagnetic waves. Some examples of electromagnetic waves include visible light, microwaves, and infrared light. The sun is the most significant source of radiation that you'll experience on a daily basis. However, all objects, even you, emit radiation and release energy. When radiation is emitted from one object and then absorbed by another, the result is often a transfer of heat. Like conduction and convection, radiation can transfer heat from warmer to cooler objects. However, radiation differs from conduction and convection in a very significant way. Radiation can travel through empty space, as it does when it moves from the sun to the earth. All right. So there are our three kinds of the way that heat is transferred: conduction through direct contact, convection by that current of movement of liquid or gas in that circular current, and then radiation through waves, through those electromagnetic waves. So let's see if we can complete this chart. So at one point, you're going to have to give me an example. And then these two here, you're going to have to tell me whether it's conduction, convection, or radiation. So for the first one, it says when you put some food in the microwave, it gets hot. Would that be conduction, convection, or radiation? Let's fill in this space. Give me an example of conduction. So going back up here, conduction, remember, is through direct contact. So give an example of conduction. And then a heater on the first floor of the school makes the air on the second floor warm. Would that be conduction, convection, or radiation? All right, so putting food in the microwave, microwave's a big hint there. Microwaves would be radiation. An example of conduction, well, you could have come up with several, but anything where direct heat is directly it's direct contact. So like if you put on gloves and your hands are cold, then that would be an example of conduction. If you put say you put a heating pad on your neck or something, that would be conduction. Anything through direct contact. The heater moving from the first floor to the second floor, got that movement of air, that would be convection. All right. So some practical uses of radiation here. So this is some real life stuff. Do you think that you could cook your food using the energy from the sun? Using a device called a solar cooker, you could. A solar cooker works by concentrating the radiation from the sun into a small area using mirrors. Solar cookers aren't just fun to use, they also help some people clean food. So here's a woman in a refugee camp. Where she is using this solar cooker here. It says this woman who lives in a refugee camp in the Sudan is making tea with water that she boiled in a solar cooker. For many people living far from electricity or a source of clean water, a solar cooker provides a cheap and portable way to help sterilize their water. This helps to prevent disease. And then over here, here's a woman that's using a solar cooker as a hobby. This woman demonstrates how her solar cooker works. Many people like to use solar cookers because they do not require any fuel. They also do not release any emissions that are harmful to the planet. So just kind of some cool kind of real life examples of using those solar cookers. All right, so now what we're going to do is go ahead and answer these questions here. So this is our review for the lesson. So thermal energy is the total kinetic energy of all the particles in the substance. If two objects are at the same temperature, the one with the more, fewer, or the same amount of particles will have the higher thermal energy. Back to the question about the soup and the tiger and the cat and those kind of things. Which one's going to have the higher amount of thermal energy? All right. Number 19, heat is the energy transferred from an object at a higher temperature to the object of a lower temperature. Heat always flows from cold to hot to cold, left to right. Number 20, heat can change the state of a substance. Adding heat to an object causes bonds between particles to form, break, combine. This is what allows the state to change. And let's see. There are three main ways to transfer energy as heat: conduction, convection, and radiation. Conduction is the transfer of energy from a warmer object to a cooler object through a gas, empty space, or direct contact. Number 22, energy from the sun travels to Earth through conduction, convection, or radiation. All right, let's look at our answers real quick. So two objects are at the same temperature, the one with more particles, because we're talking about the sum. So if you have more particles, you're going to have more thermal energy. Number 19, heat always goes from hot to cold, the warmer object to the colder object, higher temperature to the lower temperature. If you add heat to an object, so we're going to heat it up, it's going to cause the particles to break. So by adding heat, we're going to make them move faster and the particles are going to break. Conduction is that direct contact. And if it's coming from the sun, we know that's radiation. All right. All right. Suppose you are outside on a hot day and you move into the shade of a tree. Which form of energy transfer are you avoiding? And explain your answer. So which one of these forms of energy transfer are you avoiding and why? All right, this finishes our lessons on our textbook lesson on thermal energy. We will go ahead and move on to our next activity.